Good morning to one and all. Myself Divya. Today my topic is about introduction to wavelets. Overview of this topic is wavelet. A small wave, wavelet transform, convert a signal into a series of wavelets, provide a way for analyzing waveforms bounded in both the frequency and duration, a long signal to be stored more efficiently than the Fourier transform, be able to better approximate real world signals, well suited for approximating data with sharp discontinuity. Forest and the trees. Notice the grass features historical development. In 19th century, Joseph Fourier with the theory of frequency analysis, and in 1960 to 1980, Ronald and some scientists has developed mathematical transformation. Why? To obtain a further information from the signal there is not reliable available in the raw signal. Raw signal is nothing but normally the time domain signal. Preceded signal is nothing but being transformed by any of the available mathematical transformations. Fourier transformation. The most popular transformation is known as Fourier transformation. Frequency analysis. Frequency spectrum be basically the frequency component, spectrum component of that signal. Show that show what frequency exists in the signal. Fourier transform. One way to find the frequency content. Tell tell how much each frequency exists in a signal. Stationary of the signal. Stationary signal. Signal with the frequency content unchanged in time. All frequency components exist all at all the time. Non-stationary signal. Frequency changes in time. For example, chip signals. These are the graph stationary and non-stationary signals. Nothing more, nothing less. Frequency transformation once gives what the frequency component exists in the signal. Time and frequency information cannot be seen at the same time. Frequency, time frequency, time and frequency representation of the signal is needed. Time Fourier transformation. The, the segment of signal is assumed stationary. The 3D transformer. Here we can see the formula integral x of t into omega into t minus t dash into e power minus j 2 pi ft into dt, where omega t is the window function. Drawbacks of STFT transformer. Unchanged window, dilemma of resolution. Narrow window means poor frequency resolution, wide window is the poor time resolution. Heisenberg uncertainty principle cannot know what frequency exists at what time intervals. Multi-resolution analysis, wavelet transform, an alternative approach to the short time for Fourier transform to overcome the resolution problem. Similar to the STFT transformer, signal is multiplied with a function and analyze the signal at the different frequency with the different resolution. Good time resolution and the poor frequency resolution at high frequency. Good frequency resolution and poor time resolution at low frequency. More suitable for short duration of high frequency and longer duration of low frequency component. Wavelet transform, an alternative approach to the shortest time Fourier transform to overcome the resolution problem. Signal is multiplied with a function. Here is the principle of wavelet transform. Split up the signal into a bunch of signals representing the same signal but all corresponding to the different frequency band, only providing what frequency band exists at what time interval. Definition of continuous wavelet transform. Here we can see the formula. And wavelet is the small wave, which means the window function is of finite length. Mother wavelet is nothing but the prototype for generating the other window function. All the used window are is dilated or compressed and shifted versions. Scale is S greater than 1 is dilate the signal, S less than 1 is compress the signal. Low frequency, higher scale, non-detailed global view of signal, spam enter signal. High frequency, low scale, dilated view last in short time. Only limited intervals of scale is necessary. Here the resolution of time and frequency. Here the pink color denotes that better time resolution, poor frequency resolution, and the green part shows that better frequency resolution, poor time resolution. But whereas the upper will have better time resolution and less frequency. Each box represents an equal portion. Resolution in STFT is selected once for enter analysis. It is necessary to sample the time frequency plane. At high scale, the sampling rate n can be decreased. Scale parameter S is normally described on a logarithmic grid. Most common value is 2. Discrete wavelet transform provides sufficient information both for analysis and synthesis. Reduce the computation time sufficient, easier to implement, analyze the signal at different frequency, bandwidth different resolution, decompose the signal into the approximation and detailed information, multi-resolution analysis. An analysis a signal both in time domain and frequency domain is needed many a times, but resolution is better. Domain is limited by Heisenberg-Anselinger principle. Gives good time resolution and poor frequency resolution at high frequency, and high frequency resolution and poor time resolution at low frequency. Where high near the high frequency it has poor frequency resolution and good time, whereas in low frequency it has good frequency resolution and time less. This helps at the most natural signal having low frequency content spread over the long duration and high frequency content for the shortest distance. Reconstruction. What is the reconstruction? How these components can be assembled back into the original state without loss of any information is a process after decomposition or analysis is called as synthesis. Reconstructing the signal from the wavelet is coefficients, where wavelet analysis involves filtering and downsampling. The wavelet reconstruction process consists of sampling and filtering. Wavelet applications. Typical application fields: astronomy, acoustics, nuclear engineering, subband coding, signal image processing, neurophysiology, music, magnetic resonance imaging, speech discrimination, optic fractals, earthquake protection, radar, human vision, pure mathematic application. Sample applications are identifying pure frequency, denoising signal, detecting discontinuity and breakdown points, detecting self-similarity, compressing the image. Thank you.